Hello again everyone, welcome back to ptet.chemistry channel. So in this tutorial video, I'll continue these topical MCQ questions on topic 2, which is just my classification of atomic structure. Alright, so atomic structure is a quite important topic in A-level chemistry because it encompasses everything. It encompasses and explains a lot of things that you will learn in the subsequent topic. Alright. So in this question, we have a possible path of subatomic particles, which means that, really small, like protons, neutrons, and electrons. They move in an electric field. So electric field can have positive or negative terminal, and this is in a vacuum. So the electrons are moving towards the positive terminal, which makes sense because electrons are negatively charged. They will be deflected towards the positively charged terminal, to which they are attracted towards. Neutrons have no charge. If neutrons have no charge, they will not be deflected at all. They are not deflected. They just travel in a straight line in an electric field. Protons are of course positively charged, and they should be deflected towards negative terminal, but this is towards the positive terminal, so this is incorrect. In fact, positive get attracted towards negative. So only 1 and 2 are correct and not number 3. These kind of questions are very popular as well, and they can ask you in a theory level setting instead of just in paper 1. In this next question, when we form ionic compounds, the elements generally form an ion with the electronic structure of a noble gas. So which ion does not have a noble gas electronic structure? So the noble gas occupy the group 18, or what you would call the group 0 from your you call it group 0? I think you use the Roman numeral actually back in GCSE or IGCSE, but then I think in A-levels they prefer you to use the numerical value as shown on the periodic table that you have been supplied with at this particular level. Right, let me just write that a bit better and a bit clearer. So I'll cancel out the group Roman numeral with an 8. I'll just resort to using this group 18, using this kind of numerical expression for the group number from now onwards. So we know iodine is group 17. 7 outer shell electrons, gain 1 electrons, it will have noble gas configuration. Rubidium is group 1 and it has 1 outer shell electrons. When you lose an outer shell electrons with a +1 charge, it will become a noble gas. You will have a noble gas configuration. Strontium is in group 2. When you have the +2, you will lose the 2 electrons, and then you will have noble gas configuration. I purposely moved to D because I could see the answer is definitely C, where tin, SN refers to tin, and tin is in group 14. Okay, so you should really know your periodic table inside out, especially like some of the common one that you keep on using and encountering time after time. Yeah, so this is group 14, 4 outer shell electron. You only lose 2 outer shell electrons, so you haven't really obtained noble gas configuration yet. In this next question, so we have successive ionization energy, okay, of element X and Y. As you can see, most of it remain roughly the same, and for each successive ionization energy, it become more and more endothermic. It require more and more energy to remove the subsequent electrons, because you're already positively charged and you want to remove electrons from something which is positively charged to become even higher in the positive charge that you have. So obviously it is not as so favorable. That's why it requires more and more energy. However, we see this kind of thing where we have a drastic jump. Okay, this drastic increase or drastic jump in the successive ionization energy indicate to us that we are not just removing from the same outer shell anymore. This thing is removing from the inner shell. So this thing is removed from inner shell, and the inner shell is closer to nucleus. And when you are closer to nucleus, it's so much harder to remove because of stronger attraction towards the nucleus, because they are much closer to the nucleus, and that's why it takes so much more energy suddenly to remove the electrons here and here. So looking at that, the straight line is the Y, right? Okay, so let's look at Y first. So the biggest jump for Y is between the 5th and the 6th ionization energy. So the 6th electron to be removed for Y, which is the bolded line, meaning to say that the 6th electron is from the inner shell. Therefore, only 5 outermost shell electrons, or 5 valence electrons. Therefore, we're looking at group 15. Whereas if we are looking at the dashed line, which is for X, we see that the biggest jump in successive ionization energy is between the 7th and the 8th ionization energy. So meaning to say the 8th electron to be removed is from the inner shell, which is closer to the nucleus and more strongly attracted to the nucleus, and therefore indicates that there are only 7 outer shell electrons. Only 7 outermost shell electrons, or what I like to call it valence electrons, and therefore group 17. So we're looking at which statement is correct. Is there anything? Okay, an atom or element X need 1 extra electrons. Element X is in group 17, so you do only need 1 extra electrons for a full outer shell, so that is correct because X is group 17 with 7 outer shell electrons. An atom of element Y need 3 extra electrons for a full outer shell. Group 15, you need 3 extra electrons to supplement your 5 valence electrons, your 5 outermost shell electrons for a full outer shell. So it seems like A is correct, okay, and we already reached the answer. But I'll just very quickly go through the other options and to convince you why they are not acceptable. An atom or element Y has 5 electrons in the 3p subshell. So we established that Y is group 15. It has got 5 valence electrons, okay, but this is saying in the 3p subshell. So if you look at group 15, it's actually the 3rd element in the p subshell, so it's actually 3p3, not 3p5, because you also have the 3s2, 3p3, so 2 plus 3 give you 5 outer shell electrons, so B is wrong. Element X has an oxidation number of +7 in most of its compound. So yes, you got 7 outer shell electrons, which also mean that the group 17 halogen can have +7 oxidation number, but the incorrect bit is most of its compound. Okay, it's not most of its compound, it's very little of its compound. Mostly the group 17 element would be -1 oxidation number because they really like to gain 1 extra electrons. Okay, in that sense, yeah. When element X combined with element Y, the bonding is ionic. You're trying to combine a group 15 and a group 17 element, which are very non-metallic and non-metallic, further to the right of the periodic table. They are unlikely to be ionic. They are more likely to be covalent, where they are better off sharing electrons rather than transferring electrons from one atom to the other, which would cost you a lot more energy. Question 34, so this next question. In which pair do both atoms have 1 electron only in an s orbital in the ground state? Only 1 electron, okay, in the s orbital. So if we look at calcium and scandium, so calcium, the configuration from the periodic table, if we start from argon, is 4s2, and then scandium will be argon 4s2 3d1. So both of these, they have 2 electrons in the 4s, so you can cross that out. Copper and beryllium. Copper has a unique electronic configuration in the sense that it is not 4s2 3d9. It's not this because it would much prefer essentially the paired electrons in the 3d orbital. They repel less than the paired electrons here. So what we do instead is that you only have 1 electron in the 4s, and you have the other electrons being promoted to the 3d because they repel lesser being paired up in the 3d orbital compared to being paired up in the 4s orbital. Beryllium, on the other hand, is a group, it's not argon. Beryllium is only 4 electrons, so I mean you could start from helium or you could just write the whole thing out, but there's basically 2s2, and this is not what you want. You want 1 electron only in the s orbital, so I can cross that out. In fact, I can tell you C is not the answer as well, because as you know, helium has a fully filled outer shell electrons. Of course, I could show you 1s1 for hydrogen, only 1 electrons, and this 1s2, So this is what I meant by fully filled out s orbital, which leaves us the answer as being D, and that makes sense because lithium is just 1s2, 2s1 being a group 1 metal, and chromium, just like copper, is another strange one. It is not going to be 4s2 3d4. For the same reason, the paired electrons in the 4s orbital, they repel more compared with the unpaired electrons when I fill in the 3d, which will give me 3d5 and 4s1 as the most stable ground state electronic configuration for chromium atoms. So I have one electron in the 4s and I have one electron in the 2s. So lithium and chromium is indeed what I'm looking for. Atoms have, both of them have one electrons in the s orbital in their ground state electronic configuration. This is the last question of this 5-question tutorial series on atomic structure. So what can we deduce about element X from the graph? So we can tell that we have a jump. We have a jump from there to there. We also have a jump from there to there. Well, it started out from the outermost shell electrons, so we can say that there are 2 outer shell electrons, so 2 valence electrons only, because the first electrons, then the second electron being removed, then you get the big jump. Then you have the 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, and you've got 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 electrons in the inner shell that is being removed, and then this is from the inner shell again, like the one further in. All right. When you say it's a D block element, that's unlikely, because for D block elements you also have more than 8 electrons in the inner shells. Yeah, is that what I'm trying to say? No, that's not really what I want to say. What I'm trying to say is that there is easier concept to think about the D block elements than looking at this. This is most likely a main group element, but I guess the easiest thing to think about this would be it's not in the second period, because if you look at it, if you start from lithium, lithium only have what am I talking about? So this is the in fact you can tell that there are 3 electrons in the inner shell, so it continues. Because if you think about the lithium or the neon, that this is the first shell, the second shell, and the third shell. The first shell already 3 electrons. It's impossible for it to be the 1s2. All right, so that's why we can cross this out. All right, so this one only have 2 shells, whereas what we have shown here is that 1 shell, 2 shell, and 3 shell, and this is not even confirmed that it's the innermost. All right. As for group 2 and group 3, the biggest jump is there. Of course, there's another jump there, but it is from the inner shell. So we can say that there are 2 valence electrons. It makes sense for it to be in group 2. So in the old days, well, not so old days of 2007, they were still using the Roman numeral. These days, you would have seen the question as being group 2 and group 13. All right, so very evidently, C is the obvious answer. Okay, we don't choose option B being a D block element for obvious reason, as I mentioned just now, because you will lose from 4s, then you will lose from the 3d. So it's not as simple as 8 electrons being removed like this, and here only has 2 valence electrons like that. So it's not really a D block element. Okay, so this is the end of this 5-question series on atomic structure. And if you enjoy these tutorial videos, and check out my other created playlists, as well as other topical playlists for more useful content before you actually move on to a real paper tutorial. So make sure you subscribe by clicking the button on the bottom right. Share the channel with friends, chat group, social network, your juniors, your seniors, whoever you think the channel might be useful for. And thank you for watching, and I'll see you in the next video.